Welcome back to the channel. Today, we'll be finding the resultant of these multiple forces. I saw this question and I feel it would be great I share it with my audience. The first thing I want us to do is to label the forces. I'll call this F1, we'll call this F2, F3, F4, and F5. The next thing we'll be doing is we'll be finding the X and the Y component of these forces. Then we'll sum them up together. We'll pick the X component and sum them together, and pick the Y component and sum them together. Now let's create a table where we'll sum these forces. Now I've created a table. I've labeled it F, Fx, and Fy. Now let's get back to our diagram. Now for the first F1, F1 will have an X component. Here is my X component in this direction. It will also have a Y component. And here is my Y component. Now, so that Fy, the Y component of 1 over F1, obviously is equals to sine 40. That is, F1 of Y over 20 newtons is equals to sine 40. Fy of Y is equals to 20 sine 40. Same thing happens to the fx of 1. But if you note, the fx of 1 is in the negative direction. So that this will be equals to minus 20 cos 40. Now let's look at the f2. For my f2 is upward, so I'll have my y component this way, and also it has its x component this way. So that this is Fy of 2, and here is Fx of 2. And for my Fy of 2, Fy of 2 over F2 is equals to sine 50. So that Fy of 2 will be equals to F2, which is 12 Newton, sine 50. Same thing will happen to Fx of 2. Fx of 2 will be the same thing as 12 cos 50. Now we are left with F3. If you look at F3, F3 is on the x-axis. Here is F3 directly on the x-axis. So Fx of 3 will be equals to 10 Newton, while Fy of 3 will be equals to 0 because it has no y component. Now let's take a look at F4. For F4, it will have an x component and a y component. Here is the x component in the positive direction, but the y component, here is the y component in the negative direction. So that for F4, we'll be having an fx of 4, which is in the positive direction, will be equals to 15 Newton. F4 is 15 Newton sine 30. And my Fy of 4 will be in the negative direction, which will be minus 15 cos 30. And lastly, I have my F5. My F5 is a 16 Newton in the negative direction. So that Fy of 5 is in the negative direction, is on the negative axis of y, and is equals to negative 16 Newton. But fx of y, fx of fx of 5, this is 5, fx of 5 will be equals to 0 because it has no x component. Let's place this on our table. Let's collect our figures and put it in our table. Fx of 1 is 20 sine Fy of 1 is 20 sine 40, and 20 sine 40 is the same thing as 12.855. That is, here I'll have 12.855. Now let's pick our Fx of 1. Fx of 1 is minus 20 cos 40. Note the negative sign. Will be minus 20 cos 40, that's minus 15.3. then F2. For F2, we have F2 of y, which is 12 sine 50, and Fx of 2, which is 12 cos 50. We can pick them individually. That is, F2, the x component, is the same thing as 7.713, and the y component is the same thing as 9.192. That is for the F2. Now, next is the F3. For my F3, I only have an x component, which is 10 Newton. That is straightforward. That's 10 Newton. And here is 0. Next is my F4. For my F4, I have 15 sine 30 for the x component, and the y component is minus 15 cos 30. Where so many students make mistake is at the signs convention. Please note the sign. That is, the x component for x4 will be 7.5 and minus 12.99. And finally, I have my F5. Now for my F5, we have 16 as my y component in the negative direction, that's minus 16, and my x component will be 0. So that my x component here is 0, and my y component is minus 16. Next is to sum up each of these components. Now, if you sum up this is minus 15. Please note the negative sign. You sum it up to 9.89 Newton. And when you sum up the y component, you sum it up to minus 6.94 Newton. Now, this tells me that I have my y component in the negative direction. So my y component will be pointing downwards, while my x component is pointing to the positive direction. My x component is 9.89 Newton, and my y component is minus 6.94 Newton. Here is Newton. Now I can begin to find the resultant of these two forces. So that here will be my R. And I can now use Pythagoras theorem so that R squared will be equals to 9.89 squared plus minus 6.94 all squared. So that R obviously becomes the square root of 9.89, that's 48, that's 97.81 plus 48.20. R now will be the same thing as the square root of 146. So that R eventually will be the same thing as 12.083 Newton. Now, if R is 12.083 Newton, what is the angle at which this is hinging to the x-axis, tan theta? My tan theta obviously is the same thing as Fy, the y component, over Fx. So that tan theta is the same thing as 6.94 over 9.89. Now that is theta will become the tan inverse of 6.94 over 9.89 is the same thing as 0.702. So that theta is the same thing as 35.69 degrees. 35.69 degrees. So we've been able to find our resultant to be of the value of 12.083 Newton acting at 35.69 degrees. 5.69 degrees. With this, I hope you understand how to find the resultant of multiple forces acting at a point. Thank you for staying with us, and see you in our next class.